Oh, this is called Tura. It's offered to us through Blackboard.
Okay.
This
No,
is
I mean for the HEC-HMS.
that's the software.
But that's the software.
Yeah.
Okay, I thought you were using something to project.
No. Okay, you guys ready? Okay. I'm looking at the three of you. I'm trying to hear what you're saying. Okay, let's go. So first I'm going to create a new project here. So by the way, project 2 is doing exactly what I'm going to do here with a little more. And I'll post it online today. So if it's not clear, you guys let me know. And I'm trying to make the, was the video helpful last time, by the way? Did you ask? Okay, so I think, yeah, we're recording.
And it does pick up your voice.
It does. So you have to live with that. I mean, you can always mute it. So I'm going to create a new project. And you can call whatever you want. Doesn't really matter. I'll just save here. And let's use US for now. So I do have a project here. I'm not sure I'm going to be able to use this resolution, but let's see. So I talked about components, right? Here they are. So if I click here, you can see my basing, meteorologic. Oh, I could have looked at here, meteorologic. Yeah, I do get it, right? And my control file and a time series data manager. I talked about these four, so we're going to be using them. So I'll start off with a watershed. So I'm going to click here. I'm going to see new. Just give me a new basing. Okay. And now I have a watershed. If I click here, it gives me this user interface here where I can start to create things. And also gave me 1, 2, 3, 4, 5, 6, 7 icons here, which I'm going to use to construct my watershed. So the first thing I'm going to start off is with a sub-basing. So if I click here and I click here, I got a sub-basing. And I'm just going to say, yes, go create. Here I am. I have a sub-basing. In our case here, we have two sub-basins, A and B. So I'm going to create another one right here, and I'll call sub-basing 2. So I do have two sub-basins now. And I also wanted to have an outlet. Which is this guy. Just call it sink. I'm going to call it outlet. Which is here, which will get all the water. That's the end of it. Think of it as a bucket that's collecting all the water that's coming out. Right? You're looking at me puzzled, Megan, yes? Okay. Okay, what else do we need? We need a river. There you go. Here, rivers are called reaches because they could be a channel, they could be a stream, or they could be a big river. So I'm going to add a river that's going to go from sub-basin 1 to outlet. I'm going to call it reach 1. That's fine. Now, if I expand my basin here, I can see my elements. We're going to work only with these 4 elements for now. For project 2, you have more elements. But if you know how to do one, you know how to do as many. So if you click here, you can see it asks you for some information. And this other panel here lets you input information to your components. So why don't we start off with sub-basin 1? It's annoying because I can't see them. Okay, that's kind of better. So first thing is asking me is, who is downstream? Who is downstream of sub-basin 1? It's our reach, right? The outlet is downstream too, but the outlet is downstream of the reach. Who's immediately downstream? That's what we're looking for here. That is very important here. Downstream, remember that. It will save you a lot of time when you're doing project 2. Downstream is how you connect things. It's asking you who is immediately downstream. So it's how you connect things. And then it's asking me for the area. Let's say is what? 12. And we're going to work with a loss method and a transform method. And we're not going to do base flow. So base flow method is going to be none. Yes, I'm sure. And I'm going to use the SCS curve number. Yes. And I'm going to use the SCS unit hydrograph as a transform method. So here's how I set up my model for each subbasing. Right? Okay. There are other methods out there. For example, initial and constant. So if you want to set a very simple thing that's constant over time, you could do that. We're going to do curve number because we know how to do it, so we're going to go for it. Since we chose curve number, what is it going to ask me when I go to the loss tab? What is the curve number? There we go. Curve number. So let's say curve number here is 20. How did you get that? GIS, the table. We went through that, right?
Is it conservative values or?
20 is pretty low, right? So yeah. Now I'm going to go to transform. I'm using the SCS unit hydrograph. What is it asking me? It's asking me the lag time. Remember we calculated those? It was on exam 1. At the end of exam 1, we did this and we got lag time. So let's say it's 60 minutes. And I'm done setting up subbasing 1. I'm going to go do the same thing for subbasing 2. Let's say this one, the area is 15 square meters. And I'm going to use the same curve number. Okay. The unit hydrograph, yes, and no base flow. Okay. So now I'm going to say my curve number here is 80. Much higher.
When you say there's no base flow, does that mean it's like a dry pond? Like there's nothing in the river?
Yes.
Yeah.
That's exactly what we're doing. It doesn't need to be a dry pond. It could be our GMU stream. You know, if you walk there in a dry day, it's empty or almost empty. Or even if you weren't, if you wanted to do a design based on the flood itself and there's a base flow that you're fine with that's there all the time, you could just say there's no base flow. As long as you know what you're modeling on top of. What you could also do is when you go to base flow, you could say we're losing water to the ground through the stream, which could be very realistic in some cases. So you could choose one of these methods to lose water through the bottom of the stream, right? Okay, curve number, lag time, let's go with 70. Now I'm going to go to my reach. So who's downstream of my reach? Outlet. There you go. And what's the routing method we want? Muskingum, the one we used. So when I go to routing, what is it going to ask me for? Hey, there's 2 of you sleeping. That's passing the threshold. Yes and yes. I'm watching you. And he's not even waking up. That's bad. You need to have coffee, Gerald, before you come to class. What's the 2 parameters that I need for Muskingum? What is he going to ask me? What? No, it's not C and D. We did it last week. It's on the homework. Oh, you missed class. No, you missed reservoir. You didn't miss that. You're not off the hook. X and K. We use those, right? You're going to use it for homework. Everything is connected here. There's no mystery. You know, it's not like it's a lottery thing. What's it going to ask you? No. If you're using Muskingum, it's going to ask you for X and K. That's what the method needs to run. So I'm going to say K 1 hour and X 0.2. And you're seeing I'm doing a lot of guessing here because I just wanted to show you the technology. The theory we already covered, so it should be clear to you guys where these things are coming from, although it doesn't seem so, but we've been there. Okay, so what am I missing here? What doesn't look right here? If you look at my, yes, sub-basin 2 is just floating up there. So I probably forgot to say what's my downstream, and I did, none. So what's my downstream? Outlet.
Why isn't it?
Then, yeah.
That's a great question. Why? And now I did connect. Why am I connecting this to the outlet, not to reach one? Why? The answer is here.
Because the water doesn't flow through the stream.
Because the water does not flow through the stream.
So the stream goes right through it.
That's great. You guys need to work that inside your head, though. That's the assumption you do it in the sub-basin modeling approach. There is a rainfall transform thing that puts a hydrograph at the end of your watershed. We talked about that when I was standing over there. So for this watershed B, although in reality the water does travel around the watershed, our method does not account for that. Our method puts a hydrograph here. Watershed A does the same thing, but it puts the hydrograph here. So the water that comes out of watershed A routes to the river and gets here. If we were to connect watershed B to the reach, we would say that all this water comes here, which is even more realistic. In reality, this water is coming to the river sideways along the way. When does this becomes too unrealistic? If this is too big. When you guys wanted to do one big watershed, then it's really unrealistic. So that's where your engineering judgment will come up and say, how far can I go with one sub-watershed without routing water? Because you're saying that everything's coming here. Does it make sense? You guys will be connecting like 5 watersheds, so that has to be clear. So in order for you to connect them properly. Yes?
So I have one question.
Yeah.
The sub-basin outlets to the reach when the reach is like not in the sub-basin, like the river is not in A, so it outlets to the river that's just on the edge of the watershed. Say you had 3 or 4 like water sets or sub-basins. Which ones go to the stream and which ones go to the outlet?
If you wanted to cut this here by the stream and have B and C, they will both go here. But let's say instead of doing that, where's my blue one here? Instead of doing that, you're not happy with that, so why don't I make another watershed here? So C is here now. What would we do then?
Well, we have to make 2 reaches.
We have to make 2 reaches. And now we have reach 1, reach 2, with B coming into the end of reach. Actually, the beginning of reach 2, end of reach 1. And then C going directly here, so this will be the sum of 3 hydrographs out here.
So would you have an outlet where the arrow is?
No.
No. Okay, just want to make sure.
No. Yes.
So then the sub-basin of A connects to the sub-basin of B, which connects to the sub-basin of C, connects to the outlet?
No, sub-basin A connects to reach 1. Reach 1 connects to reach 2. Reach 2 connects to outlet. Sub-basin B connects to reach 2. Sub-basin C connects to outlet.
Okay, so when we do it on there, we don't connect the reaches to the sub-basins, the reach goes to the next reach.
Yes.
Okay.
Yes. Because the sub-basin does not route water, the reach does. Right? sub-basin transform rainfall to runoff. Okay? You guys are becoming water experts. That's good. You got it. That's good. I like it.
We have confused about one more thing.
Okay.
The reach, for example, right now we have one reach going from the sub-basin straight to the outlet. If
No,
you
we
want-
don't. We don't. We don't have a reach. The reach is the blue.
Yeah, that's what I mean. It
The
goes-
black thing here is just saying sub-basin goes directly to the outlet. It's not a reach.
Right.
Okay.
So the reach from sub-basin 1 to the outlet.
Yes?
Okay. Now, if you want to split that into two different reaches, how do we do that? Because I thought you had to connect it to the outlet. Isn't that a miss?
Yeah, you have to erase this and put two reaches.
Okay. Okay. But
Yeah.
you can do that. You
Yeah.
can put it arbitrary. Okay.
Yeah.
I thought it wouldn't work.
Yeah?
Can you connect a reach to another reach?
Yes. Yeah. And you would do that for Project A. So it's coming your way, but yes. And how do you connect things? Here, downstream. That's why it's important, downstream. And we're past 15 and we're still going. That's great.
Oh boy. So if we just put stuff on the blank white space and then we put the downstream on it, it will automatically connect it?
Yeah, well, yes. And that's how you connect. You cannot connect it graphically. I just tried and it didn't work.
Okay.
This is where you connect. Very important. How do you connect?
Downstream.
Yes. Hanging in there? Okay, good. Okay, so we're done, right? With basins and things? We're ready to put some water here. So I'm gonna go back to my components and I'm gonna say meteorological model manager and I'm gonna add one meteorological model. Let's see if I can find it. Here we go, meteorological models. I call it MET1, you could have called whatever you want. When I go here to precipitation, it gives me a choice of things. Being one of them, specified hydrograph, I'm going to start off with that. But one other one we wanted to be using is the SES storm. That's what we use. Remember SES type 2 was in the exam too. So things will come back at you, like it or not. I can't stress this enough. This is not a textbook class. What I'm showing you guys will come back at you, like it or not, unless you become a bartender or something. You know, then probably not. But if you keep doing this, you know, this stuff will keep coming back at you. You know, you talk to people about this stuff. So it's like I'm showing you the bare minimum things that are important towards this class. So here, specified hydrograph. There we go. So it's asking me which subbasins do you want to have rain on. Of course, we wanted to have all our subbasins to get rain, but it could not be the case. And then I should be able to put some rainfall in here. Oh, there we go. Specified hydrograph. So I need to add a rain gauge here. Why is not letting me to add a rain gauge? Probably can't see it. Okay, let's try with a time series. So there we go, precipitation gauges. So I have to add a time series. So I'm going to say gauge 1. I'm happy with that. And now I should have got, there we go. Precipitation gauge, gauge 1. Here's my gauge now, and I can add some data. And let's say you guys have been measured precipitation in your home for an entire day. That looks good. Every what? Incremental inches every hour. 15 minutes is going to be a lot of writing. So every hour. So it gives me here a table where I can put some rain in there. So let's go with 0.2, 0.3, 0.5, 0, 2, 3, 0, 1, 2, 3, 0, 0, 0. Probably have more days than I wanted to. I think I had 2 days. Okay, done. There we go. So we got some rainfall. Okay, so we have some rain going on now. It's not the best hydrograph, but it will work from now. Now I need to go back here. I need to say that this sub-basin gets rain from gauge 1. And this other sub-basin gets also rain from gauge 1. There's only one gauge. We only measure at one place, and we're saying it's raining the same at both sub-basins. That's what I just did. Does it make sense, Alex? Yeah? Okay. Okay, so we do have that. Now we're ready to set up a control file. So components, control. I'm going to say new, create new control, and I should have gotten a control file. There it is. All this is saying is, when do I want to start? So I better start at the same time I have rain. And I'm going to run it for 5 days. I'm going to run it every 15 minutes per se. So I have my control file here.
What is that doing?
What?
The control file?
The control file now is setting up your modeling run. Because you need to have a time to start your model and a time to end your model, and at every time step you want to solve the solution for. Because now we're routing this over time, right? Rainfall is happening over an entire day, and runoff is going to happen over, who knows? We don't even know. So what this is doing is it's going to solve all the methods you guys did by hand every 15 minutes, right? You guys are just getting super sneaky, right? Only 15 minutes. Come on, we're almost there. Okay. So, is it clear? Control file, yeah? You guys are used to run models, right? You're doing that for other classes too, I would assume. Yeah, there you go. Okay. So I think we have everything. We can give it a try. I might be forgetting something, but let's try. The last thing you want to do is to create a run. So compute, create simulation run. So create simulation run. I'm going to call it run 1. You might want to be creative with the names so you know what is what when you're doing this. But, you know, this is just a quick demo, so I'm just going. And before I click yes, 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 I create a run. And what this is asking me is, which basin do you want to use? We only have one, so we're going to go with that. And which meteorological forcing do you want to use? We only have one, but you could have more than one. You could have several storms. You could have several design storms that you want to try, so you can choose here. And what kind of control file do you want to use? We only have one, so we don't have many choices, but we could be doing this for different events. And then I'm going to say finish, and I do have a run. And then this icon just showed up, this little water droplet here with the bomb. We're going to click here, and if we did set up correctly, it's going to run. So let's see. So apparently it worked. It runs pretty quickly. Here at the bottom is where you get your warning results, and it tells you what's going on. So you can follow up what happened. And we did get some instability in our Muskingum here, and we should be able to see that. So now we can look at results. So if I click at my results tab, I open my simulation runs, I click here, and I can look at results both globally, so it gives me a global summary of what happened, but also per simulation component. And that's why it's good to have an outlet, because we can come here and look at our plot. And this is our resulting hydrograph. Can you guys see it? Oh, yeah, there we go. So this is the resulting hydrograph. But we can also look at per component. So, can I make this bigger? No. Yeah, it's hard to see here, but you can see in blue is my hydrograph. That's my rainfall coming up. In red is the result of my losses method. So this is how much water we're losing, or it's being infiltrated, right? And this is how much is available to run off. And this is the response of the watershed. And you can see there's 3 pikes because my rainfall event, it's 3 big rainfalls, and then I have a 2-hour interval in between. He's just like holding himself. I just gave up on the run. He's just gone. He's just dreaming at this point. You're gonna dream about hydrographs, man. Okay, 15 minutes to go, and we got to at least where I wanted to be sure to get. So you guys seen how to set up a model, how to run, and how to look at results. We're not done. I'm gonna use this 15 minutes. I'm just saying. This is how you see your first results. And if I go to my reach and I look at my plot, you can see here how much water is coming in and how much water is coming out of your reach. You can see how the hydrograph is moving through the reach. That's this here. Yes?
Why do you lose a peak? Is it like more consolidated, or why doesn't it reflect more of the precipitation after these like huge events? It looks like this like maybe one initial peak flow. I mean, there's kind of two. That first peak flow.
Yes. What's upstream of reach 1? So basin 1 is upstream of reach 1. And how much we have here?
That's right.
2 peaks. That was a great question, though. That's awesome. You're really following this, man. I like it. Yeah, there you go. Do you guys understand what he's talking about?
No. What did you say?
Yeah, that was beautiful. I loved it. That was good, man. I'm impressed.
Extra points on the next.
Yeah, right? Yeah, you got it. Here, let me back up then. You see, that's the difference, who's paying attention or not. We looked at this reach, and I talked about how the hydrograph is being routed through the reach. Right? Yes? Random, yeah? You're looking at me like, huh? That's the homework you're doing today. That's what you guys doing. This is it. Dashed line and the other line. That's how it works. This is how much water comes in, how much water goes out. I just showed you guys before a hydrograph with 3 peaks. And he's asking me what happened with the 3rd peak. How come it disappeared? What's the answer?
It's accumulation of all of them.
Is it what?
It's accumulation of all of them?
No, not at all. Huh? It's on the other one. There you go. Yes. It's on the other one. It's a different watershed. That water is not coming in here. That water is going directly in here. Why do I only get 2 peak flows for this watershed instead of 3? What's happening here? And I'm going to pull it up here so you guys can see it. What's happening? That should give you a clue. All my first precipitation here is getting infiltrated. Look at the red. It goes all the way down here. Everything gets infiltrated. There's no runoff. Why is that? Because the curve number is pretty low. I said it was 20.
What does that have to do with the specific watershed, though?
That has everything to do with the specific watershed. The curve number, it's related to land use and soil type.
Right.
That's a watershed characteristic.
I guess what I'm asking is, why does that one go away just because it was in watershed A?
Because watershed A had curve number 20, the other watershed has curve number 80,
Okay.
which means it puts a lot more water out.
So we're looking at the flow in the stream, which is like a bottom channel flow. So if it's infiltrated, it doesn't go through the bottom channel flow.
It doesn't, yeah. Yeah, exactly. Because one watershed has curve number 20, the other one has curve number 80. Right?
Right.
So that's why. Yes or no, Steven?
Yeah. Yes.
Yeah? Okay, yes. Clarice.
We oversaturate the soil, it doesn't have any infiltration on a day like that, so because it's on 2, 3, 5, 7 days. So how can we actually calculate?
We're already doing that. Because if you look at the 3rd peak, there's some blue in here.
So we can put in data with
Oh yeah, you can run preliminary conditions to saturate your system if you want to, But even with my 3 peak rainfall here, you can see that, because if it weren't for that, here would be red too. So this is already, getting saturated, and we're already seeing some runoff here in the 3rd time. So by the time that the 3rd precipitation comes down, it's running out, right? Yes, so that's exactly what you're saying. Yes, you can already see here, and it would intensify if more rain would come. Yes. Isn't this super cool? This is the best part of the class. You guys should be like super excited. We're now doing it in the computer, and you're seeing everything I've been talking about and doing it by hand in a design setting. And this is what you use in engineering companies. The only thing that's missing, that you guys won't see it in this class, and that's when you come to our grad class, you would learn how to do it, is how do I come up with these numbers that I'm just guessing here? There are methods for that. There are GIS applications to come up with these numbers. And there's GIS applications to go from a GIS-based watershed to a model setup, bringing all the information or almost all the information you need. So that's the only thing we're not going to get to it. So at this point, I'll give you some numbers to play with. The last thing we wanted to look at is, I'm going to go back to my components, and in my meteorological model, instead of specifying my hydrograph, I'm going to say that I want to do a design storm. I'm going to use the SES type 2 design storm. I'm going to include it. And now it's going to ask me, if I click here, which one do you want? We're going to go with type 2, and it's asking me how many inches. Where is that coming from? IDF. Let's say this is 8 inches. 100-year return period, for example. So I have that, and I'm going to run it. For sub-basin A, all my water got infiltrated. And you can see the format of my hydrograph now matches exactly the SES type 2 that you did for exam 1.
Is that because the curve number's so low?
Yeah. Yeah, let's see the other one. Let's see what happened to, what was the other one? Sub-basin 1? 2? There we go. We got a hydrograph here. See, here not the case. Isn't this beautiful? This is beautiful. I'm sorry you can't really see these plots, but you see it in your project too. Now let's say we're doing some design here, and we're getting, let's look at the outlet, and instead of looking at the plot, let's look at the summary table, and I'm getting a peak flow of 17,485. 17,4, is that what it is? 487. 487,000 CFS, approximately, right? You just saw a joke on your phone, right? He's just like laughing out loud. So let's see, his company now goes to this sub-watershed and puts a Walmart there. And he missed Seth Brown's class, so he didn't look into low-impact development and any of that. He looks at me like, what the hell are you talking about? So see, very common to happen. And you go there, and here, sub-basin 1 now, as a result of his work, has a curve number of 95. Because it's a Walmart, big parking lot, no LIDs, no green infrastructure, none of that. He didn't care at all. Why did I even care? Why did I even listen to that? And we run it again. Let's see what we get. You guys think it's going to change? 30,280. Now, Stephen here paid a lot of attention in the class. He did his design, he did his 100-year storm. He told his client he was safe with a 17,000 CFS design for a 100-year return period, and they did invest $1 billion building a bridge here based on that. Next year, Iodale comes in, you know, he missed 2 or 3 classes, he gets texts, he laughs, he puts a Walmart there. And now your design is at 30,000 CFS a year later for the same watershed with no climate change for the same precipitation event. You're looking at 30,000. Almost doubling your runoff here, which means your bridge is going to get on the water all the time. Or if you figure out early enough, you need to go back to your client and say, guess what? Instead of $1 million, now we need 10 million because Walmart just put it a parking lot upstream. So, or not even Walmart, the engineer that did it didn't pay attention in the green infrastructure class because he could have thought about that when he was designing his Walmart parking lot and had implemented green infrastructure and things to make sure his curve number didn't go up that much. Or he could have put it at a detention pond with a reservoir that would have hold that volume before you throw 30,000 out there. Okay, last minute, we're done. That's what I wanted to show you guys. I think we ended up with a good take-home message here. This is project 2, and have a great weekend. Yes, but there are regulations. Come on, go there. Then you get sued. If you're downstream, you can sue.
Spare me for a second.
It was a process. It happened a lot. And then, the law
So I sent you my thing.
I did. I will get back to you tomorrow. Is that okay?
Alright, yeah, do you want me to come over tomorrow or is this an email? Or?
Tomorrow you're welcome to stop by, but I need to look at it and I can see your name.
Okay, sounds good. Thank you.
What?
Stop.
Oh.